Jai Hind everyone. This is Dr. Avdhesh Gupta, Professor in Department of Computer Science and Engineering, Akgec Engineering College. So this is the next video of database management system and the topic is a distributed database. So we will discuss more about another aspect of database management system. The very good example of distributed database is Google, where you can think that there is only one server. No, there are multiple servers. That server are interlink each other, but we as a user are not aware how many servers are there, where are the server located, what is the IP address of the server. We are just using the Google. Another example is railway reservation. Do you think that a large database is stored on a single system, and that particular single system is accessed by different railway reservation counters as well as the different users? We are doing the reservation on a website and the website particular saved on a single system? No. The particular website or the servers, there are multiple servers are there, and these servers are interrelated to each other. We are not aware about the server, we are not aware about the location, we are not aware about the server name and whatever the server descriptions. We just accessing the database. So this database is a distributed over geographical location. This database is distributed over various servers. So this is distributed database. You all know that if we talk about centralized approach or centralized database, distributed approach or distributed database, a decentralized approach or distributed database, decentralized database. So centralized database is what? Where your data is kept on a single server. All of us as a user are accessing the database from the same server, the central server. Okay. Any updation, if I did some updation, every user is able to see the updated record. What is decentralized? Each computer is having different copy of databases. If I updated some record, no other computer is having this particular update. Manually, we have to update each and every computer. The distributed database is another approach, the third approach, where it combines the approach of centralized and decentralized, both approaches. It means for what? In centralized approach, there is one server. In distributed, there are multiple servers, but common information is shared among these servers. Single information, one information is available on the server. So it means decentralization is there, but centralization is also there. Also, if we are updating any record on any server, because the copy of one database is kept on the server, so this particular change is automatically changed all the system, all the server databases automatically, instantly. So if we are talking about more about the distributed database, so a distributed database is a collection of multiple logically interrelated database distributed over a computer networks. Distributed database management system is a software system that permit the management of distributed database. Yes, obviously, to access the distributed database, we have specific softwares also. Also, we have a distributed operating system also to manage this particular distributed database very effectively or efficiently. Data is spread over multiple computers, that can be sites or node. Networks interconnect that particular computers and the data shared by the users on multiple computers. So this particular site having another server, this particular site B having another server, this site having another more than one server, and all these sites are interrelated by a networks. So these site A, B, C having the common database, and we can access any of the database at any time. How? Fun is, if site A is busy, my request automatically goes to site B or site C. Which is the free, I can access that particular server. Okay, so this is how this distributed database will works. So now there are different types of distributed database. One is homogeneous, another is heterogeneous. Homogeneous, it means similar type of, identical. Heterogeneous, it means different types. So in homogeneous distributed database, all sites have identical software. are aware of each other and agree to cooperate in processing of user request, because they all server having same identical software, same database and exactly same thing appears to the user as a single system. We as a user do not know about where is my server. We understand that there is only one server because these all servers are identical. The basic goal is to provide a view of a single database and hiding details of distribution. This is a homogeneous. And if we talk about the heterogeneous, then different sites may use different schema or different software or different interface. The difference in schema is a major problem for query processing, because if schema is different, then we can say this particular name is given to this attribute, another database having different name. So how can we process the query? So this is a major issue. Difference in software is a major problem for transaction processing also. If we are using different types of software, then also the site may not be aware about each other and may provide only the limited facility for cooperation in transaction properties, which are the same. So we can say that heterogeneous distributed database is not useful for us. For better, for simplicity, to making a good functionality, homogeneous database is very good for a distributed database. The basic goal of heterogeneous distributed database is integrate existing database to provide useful functionality. Like for example, in India, we are having this type of database. In another country, they are having this type of database. So we can correlate this existing infrastructure and then making distributed approach. But this approach is not good for further processing. Local and global transaction, or local transaction access data in the single site at which the transaction was initiated. But what will happen if the server is busy or the server is not able to process that particular transaction? Then this particular transaction is requested another server to process it. Then it is treated as a global transaction. A global transaction either access data in a different site different from the one which the transaction was initiated, or access data in several different sites. If I am accessing the information and if the information is not available at particular site, so it can access another site also. So if I am accessing different sites, then it is called global transaction. If I am accessing only one server, then it is a local transaction. If that particular server is busy and this particular transaction goes to another server, then also it is a global transaction, because my request is not processed at the particular server. So it is also the global transaction. But for me, it is a local transaction. Distributed database storage. Assume a relational data model, that is replication, fragmentation. Third one, replication and fragmentation can be combined. So how can we save the data on a distributed database? Replication, it means same identical copies can be kept, can be stored on different sites. So it is a replication. Fragmentation, a huge database can be broken into several parts. Like for example, if you are having millions of records, so what we can do? We can do millions of records can be broken horizontally. Half millions of database and records are kept in one server. Next millions of records are kept in another server. In a banking also, you are saying that if you are asking the transaction of last year, so bank officials say, come again, come after 5 minutes. So they have to access that particular server. Only then they are able to access the last year database. So this is the fragmentation. Replication and fragmentation can be combined in somehow, in somewhere, like in banking system also. The relationship in partition into several fragments and system maintain several identical replica of each such fragments. Both properties can be combined. Okay. So next, data replication. A relation or fragment of a relation is said to be replicated if it is stored redundantly in two or more sites, the same copy. The full replication of a relation is the case where the relation is stored at all the sites, and partial replication is where the fragments are replicated at different sites, but each site do not contain all the fragments. It means partial fragmentation. Okay. Data fragmentation. Data fragmentation can be understood by horizontal, vertical and mixed also. So division of data, division of the relation R into fragments R1, R2 and Rn may contain sufficient information to reconstruct relation. Means what? In normalization also, you are you are dividing the large database based on the normalization, normal form 1, 2, 3 and you are breaking database into small chunks, na? Because you have to remove some redundancy, the anomaly, insertion anomaly, deletion anomaly, update anomaly. So these anomaly are basically that is related to a database, but we are talking the database. So we can break the database on the basis of horizontal, vertical or mixed. What is horizontal? If there are millions of record, you can bifurcate the database as first half million of record, next half millions of record. So there are two horizontal, first half, second half. Vertical fragmentation, if there are multiple columns are there are number of columns are too large. Millions of records are, millions of columns are there. So we have to do the vertical fragmentation in such a way, we have to use a normalization also. So that after combining these two fragmented, vertical fragmented database, we cannot lose any information. If we are losing any information, the vertical fragmentation is not a good approach. Okay. So majorly, maximally, if we have already normalized a database, there is no need to do vertical fragmentation. Only horizontal fragmentation can work because time span, after a long time span, there are several records are there. The database size increases over the time. So vertical fragmentation is the example where we do normalization. So vertical fragmentation is not a good approach to do vertically fragmented. Mixed fragmentation, yes. If there are large database and we have to do horizontal, and then also think there are multiple columns are there, we have to divide that also, so we can divide it also. But mixed or vertical is not suggested. Okay, horizontal fragmentation is good, but ऐसा नहीं है कि vertical नहीं कर सकते. We can do that also, but keep in mind that after combining these fragmentation, we can get the original database. If we are not getting the original database, the fragmentation is wrong and it is not suggested. Horizontal fragmentation, each tuple R is assigned to one or more fragment and each tuple of the global relation must be presented in at least one fragment. Usually, tuples are kept at site where they may be used most to minimize the data transfer. The fragments may be disjoint or overlapping. Disjoint is a tuple appears in only one fragment and overlapping a tuple appears in more than one fragment, then it is called overlapping. This is horizontal fragmentation. See, horizontal fragmentation, this is how we can create a large database into two different parts. The first is select the branch name Hillside from account and select the branch name Valley View. So this is a horizontal database. We have to divide the database based on horizontal basis. Some records are kept in this database, some records are kept in this database. So horizontal fragmentation is a very good example and very good approach to break the database. Vertical fragmentation. The schema for the relation R is split into several smaller schema. Fragmentation basis on the attributes. Basically follow the normalization rule also. Each attribute to be presented at least one fragment and all schema must contain a common primary key. It means common primary key, it means the normalization approach to ensure losslessly join property. A special attribute, the tuple ID, may be added to each schema to serve as a candidate key also. If we are going beyond the normalization, then we have to do this one to do vertical fragmentation. Okay, let's see. This is a vertical fragmentation. Like for example, the branch name, customer name, tuple ID, account number, balance and tuple ID. Tuple ID is the common. So we have to break. We can break this in normalization also. But here also, if we are using vertical fragmentation, so we have to do pi, means projection on branch name, customer name, tuple ID from employee information and this projection on account number, balance and tuple ID from the employee information, where the tuple ID is common. If we combine these two databases, no information will be lost. Means the combined the R relation we can get the R relation by combining these two, by joining these two vertical fragmented databases. Mixed fragmentation, where horizontal and vertical and horizontal both approach. First horizontal, then vertical, or vertical first and then horizontal. Any approach we can use it. Data transparency means what information we can share with the user. Degree, the data transparency is the degree to which system user may remains unaware about the detail of how and where the data item are stored in the distributed system. The user is completely unaware, but every information is kept secret? No. So, different types of transparencies are there: fragmentation, replication and location transparency. So, we can say that yes, we can keep secret where and how our database is stored, but not with all the users. There are different types of user category, or we can say there are different types of transparency categories are there. So, we can share some information with that users also. So, see what type of information we can share. In fragmentation transparency, the users are unaware about how our relation has been fragmented. This is called fragmentation transparency. The user is unaware. Replication transparency, user is unaware about what data objects has been replicated and where the replica has been placed. Location, user is completely unaware about the physical location of the data, where my data is stored. So, these three types of transparencies are there, where we can hide this type of information in this type of transparency. In fragmentation, we can hide the fragmented information. In replication, we can hide the replicated information. In location transparency, we can hide the location of the database. Naming of the data item. How can we name our data? So, this is the naming convention. The criteria is every data item must have single wide unique name. Unique name is must. Every entity or every database, every site, every location, every server that has the database has unique name. It should be possible to find the location of data items efficiently if we are using unique name only. Like for example, if you are using IP address, and IP addresses are unique in a network, and we can very easily find the unique IP address. But if there are duplicacy, so there are multiple IP addresses are there which are same. This is not done, na? So each database name is unique. It should be possible to change the location of data item transparently. If we want to change the location, we can change it very easily. The site should be able to create a new data item automatically. We can create new sites, new database also. Centralized scheme, the structure, advantage, disadvantage. Structure, name server assign all name, each site maintain a record of local data item, and site ask name server to locate non-local data item also. The advantage, satisfy naming criteria 1, 2, 3, and disadvantage, do not satisfy the naming criteria 4. Name server is a potentially performance bottleneck resulting in poor performance, and name server is a single point of failure. If it crashes, then the site will not run. Okay. Now, distributed transaction. If our database is kept on the multiple servers, it's kept on the multiple locations, then if we as a user want to do some transaction, like for example, we have already discussed that railway reservation or the banking system uses this distributed database approach. So, transaction may access the data at several sites. Yes, it is possible. Each site has a local manager responsible for different options are there. Managing the log for recovery purpose. If I am accessing some data, so database has the option to recover the database if my transaction getting failed. Participating in coordinating the concurrent execution of the transaction executing at that type, that particular site. Participate in coordinating concurrent execution. If there are some more operations are there, then the parallel transaction can be done. Each site has a transaction coordinator also, which is also responsible for starting the execution of transaction that originate at the site. Second one is distributing sub-transaction at appropriate site for execution if there is any sub-transaction is there and that need another site to execute. Coordinating that termination of each transaction that originate which may result in the transaction being committed at all the site. Means as the initiation of the transaction is the function of this, then closing or termination of the transaction is also the function of transaction coordinator. So these are the references. This is all about the distributed transaction. So first, one thing you must know that today's scenario, if we are talking about data, we are using some data analytics. It means there are a large amount of database is there, huge amount of data is there. Every single transaction, or if we are accessing any information on any website, it create a data, it create a row. So it means over the time, the data become larger and larger. We have to manage that data. If we are keeping the information of today's transaction only, so we cannot do the data analytics. We have to keep record of all the past days data also. So this particular huge database, for recording this huge database, we need to understand that we need several servers also. Also, if the database is too large for banking, for railway, for airline reservation, for some company databases, there are large databases there. If the server is busy at a time, we cannot access that particular server. What will happen? The reputation of that particular organization goes down. So the organization, what can the organization do? The organization can keep the same information on another server also. So that if 10,000 users are accessing a single server, but that server cannot handle 20,000 users. So that server is responsible for another 10,000. Okay. Second thing is location. Location matters. Like for example, if I am accessing the server which is available at India, I can easily access. I can easily access if I am residing in Ghaziabad, the server which is available in Delhi NCR, I can easily access. But if the server is available at Chennai, at Trivandrum, at the Kerala, then the request travel from this place to that place takes time. Takes time, na? And that particular Kerala person want to access the server that is located at their place also. So to minimize the transaction delay, to minimize the communication delay, we can do that the server location should be multiple locations are there, so that the local person can transact with the local server. So this is the beauty of distributed transaction. Yes, there are certain obstacles in distributed transaction. We have to handle this particular distributed approach very easily. So that's all for today. Thank you very much.